hand over to Robert Nicholls from East Anglia, who's going to give us a little bit more detail about the OpenCLIM project.
Thank you very much then. So I'll just try and follow on from Catherine and just give a very brief overview of what the OpenCLIM project is actually doing. And so the OpenCLIM project, well really the overall goal of the OpenCLIM project is to deliver an assessment method for the CCRA4 and beyond. So really, to try and enhance the UK's climate change risk capability. But when I talk about OpenCLIM, maybe there's two things to distinguish. There's maybe the overall vision, but there's also the realism it's a 28-month project under the UK Climate Resilience Programme. So there are aspects of what will be done in building the foundation, and then there's clearly aspects that are vision and beyond, which DAFNI very much helps us to deliver. And what we're with the problems Catherine's been outlining, what we want to do is develop and implement an advanced, open, integrated, spatially explicit, so we're talking about kilometre or sub-kilometre scale model framework around a different community of developers and users working together within the project. And DAFNI is, I think, very critical for doing this kind of project, both for the integration of what we're doing, but also, I think, for the legacy. And when we were actually writing the OpenCLIM proposal, I was talking with colleagues who'd, I think between us, we'd worked on about 20 different sort of integrated assessment models. And we observed that most of them had become redundant over time because fundamentally, we don't really support the sort of informatics. The things that DAFNI is doing for us were just not readily done within these earlier projects, and researchers, postdocs left. There'd be an update on some of the software, and the tool would be much harder to use. And so I think we really realise that DAFNI is providing that fundamental continuity and link through time. Obviously, we're talking about linking state-of-the-art models within an integrated framework to a bigger and more complex model. And as you all well appreciate from this morning, this involves substantial development, both the integrated model framework design, how we couple the models, and in the case of the CCRA, the role of adaptation is very, very fundamental. A lot of climate risk assessment models don't necessarily consider adaptation very explicitly enough. So we have to really think through how we express adaptation. And that, of course, then goes back, that's the sort of answer, really, that Catherine wants. And developing a community around this process, and then the legacy. So just to kind of show you the picture of OpenCLIM, this is sort of the outline, and this is a bit complicated. So just to sort of simplify it, if we look at the yellow box, we want to take climate scenarios. And then we want to also take socioeconomic scenarios. So we're talking about UK CP18, and then there are the emerging UK SSPs that have just been released now on to the sort of for wider use. And then when we go down from there, when we think about how the climate might change the hazard. So we think of looking at catchment models, for example, like HBV, and looking at how, for example, flows are changing, both low flows and high flows. But equally, we want to look at how socioeconomic changes are leading to changes to vulnerability and exposure. And that might be in terms of demand for housing. So we have the urban development model. I think that was mentioned this morning. And so that will model at very high spatial resolution the distribution of new housing stock. And we also have land use for the whole nation, and then land use scenarios, so that we start to get a coherent view, as Catherine was asking for, a coherent view of how things might change with different socioeconomic drivers. And then we go down to our risk assessment, where we have a range of models that we're using at high spatial resolution. And then adaptation. I mentioned adaptation. I think we recognize that adaptation can happen at the scale maybe of the house. We might flood-proof a house, but we might change the catchment. We might make a land use change and introduce, say, afforestation in the upper reaches of catchments. And so with this sort of framework, then, we can actually introduce that change in land use in the upper catchment, and then look at how that will affect the flow, so how that will also affect the risk. So therefore, we're able to think about adaptation not at multiple scales, and there's sort of and the policy choices that have been discussed in government, and also we can then begin to even intersect with other agendas, like, for example, net zero, which is obviously very strongly linked to land use, and also things like biodiversity, which again is strongly linked to land use. So we're getting quite a sort of strongly joined up view of future possible changes. What are we actually looking at in OpenCLIM? Well, we're essentially exploring 4 sectors or issues. We're looking at the future of agriculture. We're looking at heat stress. We're looking at inland flooding, and we're looking at drought and water supply. And then just to note, though, we're also considering this land use and biodiversity component expressed really through the changes to vulnerability and exposure. And all these are being simulated at high spatial resolution. And within the project, I mean, I think we're one of the, again, the disciplines I think of working in this way is we have a large number of partners. I'm not going to mention them really, we've got the logos at the bottom of the screen, and working together to really understand what is going on, and how we can produce workflows and linking models and data that really allows us to develop this system of systems simulations, and really and explore even the links between the sectors. And so we're exploring these sectors, and here is one of the agricultural workflow. This is based around the CropNet model from CEH, and looking at the different sort of inputs. Don't expect you to look at it, but just the kind of complexity of what we're doing, and we keep on discussing this, revising this, and we're doing this with each workflow, and bringing in, for example, within agriculture, fundamentally based around CropNet, but then we've introduced another model, EcoCrop, which looks at crop suitability of crops that are not growing within the UK today, so crops that might move in with a warmer climate. We're looking at links to drought and water supply, and even with heat stress, how heat stress might affect livestock are areas that are being explored, just to kind of give an example here, a flavour of the kinds of things that we are looking at. In terms of our geographic coverage, we're looking at the UK by definition. That's what the call required. And as Catherine said, we have to consider the devolved administrations. So we're looking at all administrations. We're holding a series of stakeholder events where we're engaging with each, with nationally and with the devolved administrations. We also have 2 regions which we're looking at in particular detail. The Clyde, linked to Climate Ready Clyde, which I think many of you might be aware of, and the Norfolk Broads. So a coastal low-lying region really, and then a catchment with a large city, an upland catchment with a large city in its lowland sort of reaches. And we're not modelling the Clyde and the Norfolk Broads in any more detail than anywhere else. What we're doing is scrutinising the results in more detail there to learn about how you might use the results we're producing nationally at finer scales. And with all these different groups, we are also getting them to sort of work with us within the project. So there's an ongoing, and I think via COVID, our online meetings actually have facilitated this. We're having more regular stakeholder meetings than was planned, because we were planning sort of a small number of face-to-face meetings. Now we're having more shorter online meetings. So the results that are available, we have nationally available results and for the devolved administrations, but we can also think about storing the results from these simulations at sort of local authority scales, or being able to interrogate these results so you can extract a local authority or sectors. Really, I mean, back to Catherine's challenge, I think that we'll have very rich, spatially rich and temporally rich simulation data sets, so we'll be able to interrogate them and extract information from many users beyond the primary client, which is the CCC and DEFRA with the National Adaptation Planning. With the data structure, then looking at these sort of challenges, we have the outputs, high spatial resolution. We have a much more flexible approach, which allows us to look at a sort of range of outputs and a range of different questions that emerge. I hope I made the point in this very brief presentation that we have consistent underlying assumptions. So we'll take through UK CP18, for example, the UK SSPs, and look at how they work through. And for example, if we plan a land use adaptation in the catchments, or we build houses in certain particular areas, then we'll look at the implications of that for all the hazards we're looking at. And for example, adaptation, built zoning for flooding, for example, and avoiding the floodplain, does that have any implications in terms of heat stress? I mean, so we can actually, we'll actually be exploring consistent worlds. I think the stop-start nature was mentioned. I think this is building a process and a foundation for a more continuous activity, and an activity that's probably linked to policy, but then also linked to the science process, although that obviously that depends commitment and funding. I mean, so it's a 28-month project, so things need to go beyond, but this is facilitating and establishing that foundation. I think Catherine mentioned the point about getting access to the results, and I think there is a challenge there, because when we're starting to link together lots of different models in different ways, we have a very sort of rich and fertile space for scientific research. Then we have to sort of focus in then on the specific questions that the CCC wish to answer, the metrics that they wish to use. And I mean, I think in OpenCLIM, we're spending quite a lot of time thinking about how this can be accessed by the client. And clearly there's the sort of the traditional way, which Catherine outlined, which is by experts or consultants. You know, so you have you can set up a wide range. You have an evolving system. You can add in new models, new data fairly easily as an expert, and there's a progressive improvement. So you can have that route into this. Equally, you can define a set of questions and and define a data cube, or basically a searchable database that explores the results of the models for a range of cases. So you can build a big database, and again, so this will again be driven by a client. So they define the questions they want answered, and they have at their fingertips a database that they can search and without the experts being involved. So you remove, once the database is created, you remove the expert. And then lastly, you have a web interface for tightly defined queries. I think this is not a web interface that can look at the whole OpenCLIM portfolio, if you like, of models and possibilities, but for tightly defined queries would allow a user to interact with the models and essentially use them. And I think that, and we've certainly been discussing this a lot with Catherine. Brian Matthews has been leading a group within OpenCLIM thinking about doing this. And I suppose here, I think within the OpenCLIM project, we're probably engaging with maybe a generic question for DAFNI, because this is going to come up again and again about how you make this more accessible. And so I think, we haven't cracked this problem yet, but we're trying hard to, and learning about how we can make this as accessible as possible. But I think it defines clear definition with the users of the question. So as with the data cube, you need again to define exactly what questions you're posing and develop shouldn't use the word wrap really. Basically take a defined part of the modeling framework that's been tested and we know is robust, and then it can be queried by any user with a web interface. So I think hopefully I've given you a flavor, and I'll happily take any questions on OpenCLIM now with Catherine.